Hello everyone. So today we're going to talk about another data structure called a stack, and we'll be talking about stack abstract data structure. That means we are not interested about how stack is implemented. So implementation details we are not going to talk about. Rather, we are going to talk about the features of the stack and operations that can be done on a stack. Okay. So without further delay, let's move on. So here are two real-life examples of stack. The first one, as you see, is a stack of disks, right? The second one is a stack of tennis balls. So this is a disk container and the tennis ball container. Looking at these two stacks, we can actually find the features of the stack and what operations can be done on this stack. So first, let's talk about the features. As you can see, stack has only one way in. So this end is closed, right? This end is closed. This is closed. This is also closed. So you cannot put anything using these two ends. Whatever you are putting, you have to use the top, right? So we can say that again, this is also a linear data structure, right? So it's a linear data structure. It's a container with one open end, right? Okay, and next, let's see, if you are removing something from the stack, because this end is closed, right? We can just remove it from the top. That means we can remove it from here and here. So that means if we want to put, we have to put on the top. And if we want to remove, we have to remove from the top. So as you can see, in these two stacks, this is the first one that went in, right? This was the second one. This was the third one. So when this was the sequence when what they went in, and here this is the last element that went in, right? And this was the first element that went in. But if you're taking the things out, what is going to be the sequence? So if you want to take something out, then this is going to be the first one that goes out. This is the second one, and this is the third one. So in a different, the sequence will be changed. Again, this would be the first one that goes out. Okay, so from that, we can just call this as last in, first out, or LIFO. So this is the principle that the stack follows. Last in, first out. If you remember, for Q, it was first in, first out, right? Now let's talk about the operations, the major operations on the stack. So the two major operations are like we can just, as we said, like we can put in the stack, right? Put a new disk in the stack, or we can just remove something from the stack, right? Or for a tennis ball, we can put a new tennis ball in the container, or we can remove a tennis ball from the container, right? So from this stack perspective, this is called put. This is called push, right? The put is called push, and removing is called pop. Okay. Okay. So now let's talk about let's see an let's draw a stack and try to do some operations on them. Okay, so here is a stack, and as you see, one end is closed. Let's do this operation: push, say 10. Okay, so 10 goes here. Then push again, say 50. 50 goes here. And then if I do a pop, as you know, pop doesn't take any parameter because whatever is in the top is going to be popped. I cannot pop anything else. So the top is here now, right? So 50 is out. Then do a push again of say 15. So 15 goes here. So this is also the top, right? If I do another pop, 15 is going to be popped out, and now this is going to be the top of the stack. Okay. And then, so these are the operations in push and pop. And as you can see, that pop operation, this one directly goes to the top and removes the object. So this is a constant time operation order of 1. Push is also easy, like whenever you are doing a push, say you are pushing another thing, 60, it directly goes, it knows where it wants to push. So this is also a constant time operation. You don't have to iterate through the elements to push or put some item in the stack. So this is also a constant time operation. Okay, so let's go to the Java implementation. As you know, if you're using another language, just you can find out what is the stack implementation in that language. In Java, stack is a class. So if we want to declare a stack, say stack of an object, then say I have to declare new stack class. And the operations are stack.push, stack.pop, and then there is stack.size, which returns returns the size of the stack. So I pushed once and then popped it. So this now will return 0. And then there is a stack dot is empty. This returns a boolean. So in this case, this will return true because the stack is now empty. And finally, there is another one, stack.pick. This one returns the top of the stack. But in this case, since there is nothing in the stack, it will return null. So if I go back to the previous one, if I had to pick here, this will return 60. Okay. And the pick operation is also order of 1 operation because it just goes to the top of the stack and returns the value of it. And pick doesn't remove the item from the stack. It just returns you the value that is on the top of the stack. Okay, so that's it. We'll come back with another data structure in the next lecture.